Configuring DNS DHCP and web server. Step 1. Dragging components to workspace. Open Cisco Packet Tracer. This is a network simulation tool used for practicing networking concepts without physical hardware. Go to the bottom left device panel where all available network devices are categorized. From network devices select a switch. A switch operates at layer 2 of the OSI model and is used to connect multiple devices within the same local network. Drag the switch and drop it onto the workspace. From end devices select 2 PCs. These represent client computers that will obtain IP addresses automatically from a DHCP server. Drag them to the workspace. From servers select 3 servers. Servers are specialized computers that provide network services to clients. We need 3 because one will run DHCP, one will run DNS, and one will host the web server. Drag all 3 servers to the workspace. Arrange the components logically. Place the switch in the center top area as the central connecting point. Place the 2 PCs on the left side in a vertical line. Place the 3 servers on the right side also in a vertical line. This physical layout will make cabling easier and more organized. Step 2. Ethernet connections. Click the connections icon which looks like a lightning bolt in the bottom toolbar. From the connection option select copper straight through cable. This is the standard cable type used to connect end devices like PCs and servers to a switch. In contrast, a crossover cable would be used for similar device to similar device connections such as switch to switch. Click on PC 0 and select Fast Ethernet 0, which is its network interface card. Connect it to the switch by clicking on the switch and selecting Fast Ethernet 0/1. This assigns PC 0 to the first port on the switch. Click on PC 1 and select Fast Ethernet 0, then connect it to the switch on Fast Ethernet 0/2. Now connect each server to the switch in the same manner. Server 0 will be our DHCP server, so connect it to Fast Ethernet 0/3. Server 1 will be our DNS server, so connect it to Fast Ethernet 0/4. Server 2 will be our web server, so connect it to Fast Ethernet 0/5. After completing all connections, observe the link lights on the cables and on the switch ports. They will change from red to green, indicating that physical connectivity is established and the devices are negotiating link speed and duplex settings properly. Step 3. Static IP assignment for servers before any services are configured. Servers must have fixed unchanging IP addresses because clients need to know exactly where to find them. Click on Server 0, which will act as the DHCP server. Go to the Desktop tab at the top of the server window and select IP configuration. This is the interface where you manually set network parameters. Set the IP address to 192.168.1.1. Set the subnet mask to 255.255.255.0. This mask indicates that the network portion is the first 3 octets, leaving the last octet for host addresses. Set the default gateway to 192.168.1.1. Since this server is also the gateway for the network, it points to itself. Now configure server 1, the DNS server. Click on server 1, go to IP configuration and set its IP address to 192.168.1.2 with the same subnet mask 255.255.255.0 and default gateway 192.168.1.1. Finally, configure server 2, the web server. Click on server 2, go to IP configuration and set its IP address to 192.168.1.3 with the same subnet mask and default gateway. These 3 IP addresses from 1.1 to 1.3 are now reserved for the servers and will be excluded from the DHCP pool to avoid conflicts. Step 4. DHCP server configuration on server 0. Click on server 0 to reopen its configuration window. Navigate to the Services tab, which contains all available network services that Packet Tracer can simulate. From the left side menu select DHCP. This opens the Dynamic Host Configuration Protocol configuration panel. Turn the DHCP service on by clicking the On button if it is not already enabled. Now we need to configure the DHCP pool, which defines the range of IP addresses that will be given to clients. The first field is the default gateway address. This is the IP address that clients will use to reach networks outside their local subnet. Enter 192.168.1.1, which is server 0 itself. Next, set the starting IP address for the pool. Since we already reserved point 1 through point 3 for the servers, we will start the client pool at 192.168.1.10. This gives us room for future expansion if needed. Set the maximum number of users to 20. This limits how many clients can receive addresses. Leave the subnet mask as 255.255.255.0, which will be distributed to clients along with their IP address. Now scroll down to the DNS server field. This is a critical setting because it tells clients which DNS server to use for domain name resolution. Enter 192.168.1.2, which is the IP of server 1. Without this, clients would not know how to translate domain names like www.casneb.com into IP addresses. Save the DHCP configuration. The server is now ready to respond to client requests. Step 5: DNS server configuration on server 1. Click on server 1 to open its configuration window. Navigate to the Services tab. From the left side menu, select DNS. This opens the Domain Name System Configuration panel. Turn the DNS service on by clicking the On button. DNS is responsible for translating human-readable domain names into machine-readable IP addresses. In the name field, type www.casneb.com. This is the domain name that users will type into their web browsers. In the address field, type the IP address of the web server, which is 192.168.1.3. This creates a record which maps the domain name directly to an IPv4 address. Click the Add button to save this record. The record should now appear in the DNS table below. Verify that it shows both the name and the corresponding IP address. This table is essentially a local DNS database. When clients query this DNS server with the name www.casneb.com, it will look up the table and return 192.168.1.3. If there were multiple records, they would all appear here. The DNS service is now ready to resolve queries from clients. Step 6: Web server configuration on server 2. Click on server 2 to open its configuration window. Navigate to the Services tab. From the left side menu, select HTTP. This opens the Hypertext Transfer Protocol configuration panel, which is used for web services. Turn the HTTP service on if it is not already enabled. HTTP is the protocol that web browsers use to request and receive web pages. The server is now listening on port 80 for incoming requests. Scroll down to the File Management section. This area allows you to manage the files that the web server will host. You will see a list of default HTML files already present. However, you already have a custom index.html file prepared on your computer. This file contains the welcome message and basic information you want to display. Click the Browse button next to the File Upload section. Locate your pre-prepared index.html file on your computer file system. Select it and click Open. Then click the Upload button. The file will be transferred into Packet Tracer and will appear in the list of files on the server. The web server automatically serves index.html as the default page when clients request the root directory. This means when a client browses to www.casneb.com without specifying a file name, the server will deliver index.html by default. The web server is now fully configured and ready to serve content. Step 7: PC IP address request via DHCP. Click on PC0 to open its configuration. Go to the Desktop tab and select IP configuration. In this window you have the option to choose between static IP configuration or DHCP. Ensure the DHCP option is selected with the radio button. This tells the PC to broadcast a request for network configuration. Click the DHCP request button at the bottom. This sends a discovery message to the network. The DHCP server, which is server 0, will respond with an offer containing an IP address subnet mask gateway and DNS server. Wait a few seconds for the exchange to complete. You should see that PC0 receives an IP address automatically. Since we started the pool at 192.168.1.10, PC0 will likely get 192.168.1.10. The subnet mask field will be populated with 255.255.255.0. The default gateway will be 192.168.1.1. The DNS server field will show 192.168.1.2 as we configured. All these parameters are provided by the DHCP server. Now repeat this step for PC1. Click on PC1, go to IP configuration, ensure DHCP is selected and click DHCP request. PC1 will receive the next available IP address in the pool, which will be 192.168.1.11. Both PCs now have valid network configurations without any manual entry. This demonstrates the efficiency of DHCP for automating client network settings. Step 8: Connectivity testing via ping. Before testing web access, we must ensure basic network connectivity exists between clients and servers. Click on PC0 and go to the Desktop tab. Select Command Prompt to open the command line interface. Type the command ping 192.168.1.1 and press Enter. This sends Internet Control Message Protocol echo requests to the DHCP server. You should receive successful replies indicating round-trip time and that the destination is reachable. This confirms the PC can communicate with its gateway. Type the command ping 192.168.1.2 and press Enter. This tests connectivity to the DNS server. You should receive successful replies. Type the command ping 192.168.1.3 and press Enter. This tests connectivity to the web server. You should receive successful replies. Each ping response confirms that the network path is working correctly and there are no physical or logical connectivity issues. Repeat these 3 ping tests on PC1 by opening its command prompt and entering the same commands. Both PCs should successfully ping all 3 servers. This validates that the DHCP assigned addresses are correct and that the switch is properly forwarding traffic between all connected devices. If any ping fails, you would need to check cabling IP configurations or DHCP settings. Step 9: DNS resolution and web access. On PC0, open the command prompt again if it is not already open. Type the command nslookup www.casneb.com and press Enter. The nslookup utility queries the configured DNS server for resolution of the given domain name. The DNS server 192.168.1.2 will return the IP address 192.168.1.3. This confirms that the DNS record we created is working correctly. The PC can now translate the domain name into the web server IP address. Now test web access using the browser. Go to the Desktop tab on PC0 and select Web Browser. In the URL field, type www.casneb.com exactly as it was configured. Do not include HTTP or www prefixes beyond what is shown. Press Enter or click Go. The web browser will send an HTTP GET request to the IP address returned by DNS. The web server server 2 will receive this request and respond with the index.html file. Your custom HTML file with the welcome message and basic information will appear in the browser window. Verify that the content displays correctly, including any formatting text or images you included. Now repeat the web browser test on PC1. Go to its Desktop tab, open the web browser and type www.casneb.com. The same page should load correctly on PC1 as well. This confirms that both clients can successfully resolve the domain name and retrieve web content from the server. Conclusion: the network configuration exercise is now fully complete. We have successfully designed and implemented a small network with integrated services. DHCP has been configured to dynamically assign IP addresses to client PCs from a defined pool. Static IP addresses were manually assigned to servers to ensure they remain at fixed locations for client access. DNS has been configured to resolve the domain name www.casneb.com to the web server IP address, enabling human-friendly browsing. The web server has been configured with a custom HTML file that is served to any client requesting the root directory. Clients are able to obtain IP addresses, automatically resolve domain names using DNS, and access the hosted web page. This exercise demonstrates the practical integration of three essential network services within a single topology using Packet Tracer. All components are communicating successfully and the network functions as intended. Understanding these configurations is foundational for real-world network administration and troubleshooting. This concludes the exercise notes.